Hey, welcome back to the IT office. Imagine this is your first day working in IT and your boss comes in and tells you, hey, I need to locate this device. Where is it connected? Which port? Which switch? How can you locate it? Don't worry. In this video, I'm going to explain you what a MAC address is. Okay, and how can you use that concept to find device in your network. MAC address stands for Media Access Control Address. So basically, it is an identifier for a port in a network interface card. Imagine if you have a server with 2 ports in the network interface card. Each port will have its own MAC address. Okay, so it's a identifier assigned when the network interface card is built or manufactured. Okay, so it's a physical address. There are some ways to spoof it. I will show you in later videos how to do it, but keep in mind it's physically assigned to the NIC. So let me show you in my computer. If I open the command prompt and run the command ipconfig /all, I will see all my NICs and all my ports. In my case, in my Ethernet LAN port, I only have one port. Well, you probably in the regular computer you will have only one port, but servers you can have more than one port. Okay, so here you will see the physical address. Okay, this is the MAC address. So let's take a look at the format. So this is 1A-6/DA-2B-find9-70. Okay, so these digits are hexadecimal. Okay, so we'll see 6 hexadecimal pairs. Okay, so each hexadecimal digit will represent 4 bits, remember? So in total, if we calculate 6 by 2 by 4, it will be 48 bits. Okay, so each MAC address is 48 bits long. Now, something important here. If there is something called the organizationally unique identifier, or OUI, right? Which is from this MAC address, the first 3 pairs represents the OUI. Okay, so what this represents is the vendor, okay, the manufacturer of the network interface card. For example, you will see Broadcom, Intel, maybe Cisco, Fortinet. Is the manufacturer. Okay, so if you buy 10 Dell laptops, you will see that these 3 first pairs are common, right? But now, since each MAC address for each device in the network has to be different, these 3 pairs will change, right? So for example, for each of the laptops that you bought from Dell, the OUI is 1866DA, right? But this portion will change to represent the unique devices. For example, it could be for a different device, it could be 2B5971, 2B5972, and so on and so forth. Okay, so keep in mind, a MAC address is a physical identifier unique per port in the network interface card. Okay, and the OUI represents the vendor, the manufacturer of the network interface card. Okay, so MAC addresses are relevant at the data link layer in the OSI model and the network access layer in the TCP IP model. Okay, we are going to see how switches use the MAC address to forward traffic in the network. Okay, so that's why this is so important. It's a fundamental concept. Okay, remember, physically assign, you can spoof the MAC address using software. I will show you that in some later videos, but keep in mind that it's physically assigned, it's unique per device. Okay, so now let's go to the lab. So you will see here we have 2 Windows devices, 2 switches, and 1 Kali Linux device. So if we go into each of these devices, let's go to the Windows device. You can go open the command prompt, run the ipconfig / all. You will see the MAC address assigned to the port is 000C2940C6166. Let's go to the Windows Server 3. Let's run the same command, ipconfig all. You will see that is 000C294202CD. So you see that this first portion, the organizational unique identifier, is the same as this one. Okay, in this environment makes sense because this is all being word-based devices, but you will see that the second portion, these 3 pairs are different. In this case is 4C, C1, C6, and in this case is 4202 CD. For the Kali Linux it's also different. Let me open the terminal. So I'm showing you different devices so you can mix it up a little bit, okay, and start learning about Linux and about Windows, and don't be afraid to do this, okay. So in this case it's 000C29, which is pingware. I'm going to show you later how to check this MAC address in a website, okay. But all and let's see, the rest of the MAC address is E6C5A8A. Okay, so 3 different MAC address, all with the same OUI. Okay, so now let's take a look at the switch. So if I start sending traffic, let me do a ping to the other devices. This is Windows 3 IP is 10.10.15.33, and the Kali Linux is .200. Okay, I'm generating some traffic. Don't worry about this. I know these concepts may be new for you, but let's generate some traffic so the switch can populate their MAC address table. I'm going to explain you as well how this works, okay. So but at this point just keep this in mind, okay. So if I run this command, show MAC address table, you will see these different MAC entries, okay. So this MAC will correspond to each of the devices in the network. Okay, so let me add the labels here in the lab device. So this is G2, G0, G0, okay. So each switch will use its MAC address table to identify where the devices are connected, okay. So that's why the MAC address is so important. So if you see, this is switch 01, right? Let me change the color here so you can see it clearer. So switch 01, you will see that this MAC is identifying port gigabit 02 is 000C. See that the format changes, but still is in the hexadecimal. This depends on the vendor of the switch. In this case, Cisco use this format, okay, but it's same hexadecimal representation with the 6 hexadecimal pairs and so on and so forth, so don't worry about that. So this ends in 4202 CD, so that is the MAC address of Windows Server 3. Okay, so let's confirm. Let's go to Windows Server 3. Let me open it. Let me make this smaller. So it's 4202 CD. Okay, so it's the same MAC address, right? So you will see here, right? And it's connected through port gigabit 02. Okay, so this makes sense, right? And that's how it's supposed to be. Now you see another entries in the switch, but in this case you will see that it's learning those entries through port gigabit 01, and those entries correspond to the MAC address ending in 4C, C1, C6, and 99E5000, which I guess are the Kali Linux device, E6, E5, A8A, and the Windows device, Windows 1, 4C, C1, C6. Okay, so you will think, okay, so what's going on? Why I see all these devices through port gigabit 00? So I will get more into the details of how switching works later on, but keep in mind that switches learns where the devices are connected when they listen traffic from the devices. So if you see in this path, when I send traffic from Windows Server 1 to Windows Server 3, or from Kali Linux 01 to Windows Server 3, from the perspective of switch 01, I see that traffic coming from gigabit 00. So those MAC addresses from Windows Server from Windows Server 1 and Kali Linux 01 are learned through the port gigabit 00. Okay, so that makes sense. It's learning the traffic from the port that listens to the traffic. Okay, when the packets comes in this direction from Windows Server 01 or Kali Linux 01, and it learns the traffic through port gigabit 00. Same, it will learn the MAC address of Windows Server 3 through port gigabit 02. When packets come in the direction from Windows Server 3, it will record this MAC address and will associate the MAC address to the port where it listens to traffic. Okay, so now what happens with the switch 02, this switch below? So it will learn the Windows 01 MAC address through port gigabit 02. It will learn the MAC address of Windows 3 device through port gigabit 00. Okay, and it will learn Kali Linux MAC address from port gigabit 03. Okay, let's confirm that. So let's go first. Let's go to switch 02. Let me run the command show MAC address. Okay, and let's go to Windows Server 3. The MAC address ends in 4202 CD. And if I find that here, you will see it that this MAC address is learned through port gigabit 00, which is the port connecting to switch 1. So if that traffic comes in from that direction, I will learn the MAC address right in that port. That makes sense. If I take a look at this is switch 2, let's see, Windows Server 1, it's 4C, C1, C6. Okay, so in that case 4C, C1, C6 is learning that MAC address in the port gigabit 02, which is the port directly connected to that device. And let's see where is the Kali Linux entry. I don't see it. Let me generate some traffic. 10, the 10, the 15. that 11. Let's see. Let me run it again. Okay, I see it through port gigabit 03. So that's the way it's supposed to be. Okay, so let me generate traffic also to through Windows Server 3. I will see the entry here as well for Kali Linux, which MAC address is ending in, let's see, E6 C5 8A. Okay, so from switch 01 is learning that MAC address in port gigabit 00, and in switch 02 is learning that MAC address in gigabit 03. Okay, so remember, MAC address are fundamental addresses for switching. Okay, that's why they are relevant at the data link layer of the OSI model, or the network access layer in the TCP IP model. Now remember, those are physically assigned. It comes from factory, and they have this organizational unique identifier, which is fixed and represent the vendor, and they have the other hexadecimal portion represents the unique device in the network. Okay, they can be spoofed through software, but they come physically assigned to each individual port in a network interface card. Now let me show you something else before we finish this video. Okay, now if we go to Google and we search for MAC address lookup, let me delete the drawings here. There is one that I like, this one. Okay, you will see here in this website you can do lookups for specific MAC addresses. So let me copy, for example, this one, right? I will paste it here. Okay, and it will bring me back the vendor. Okay, so you see here in this detail, this is what I was telling you. Okay, so the first 3 pairs in the MAC address represents the organizationally unique identifier. Okay, so 0000C29 represents VMware, right? And this other portion is like the specific device in the network. Okay, so with these tools you can look up the MAC address or any device in the network. Maybe you are searching for specific devices, you can do lookups and try to understand what type of device that is. Maybe you have some cameras or unknown devices, so you can do the lookup using the organizational unique identifier. I hope you have enjoyed this video. Don't forget to subscribe, like this video, and turn on the bell. So I see you in the next one.